transform of the signal x of t equal to t into u of t. It is nothing but r of t, isn't it? Find Laplace transform of the signal x of t equal to t into u of t. T into u of t is standard representation is ramp signal, isn't it? Please don't get confused with this kind of representation. This itself, t into u of t is r of t. Clear? Okay, next. Please try to solve this. What is the standard formula we have? X of t into e power minus st dt. This is a standard formula what we have to find the Laplace transform of a signal x of t, right? Now in place of x of t, what I have to substitute? T into u of t into e power minus st dt. As u of t is there, what are the limits that I have to write here?
0 to infinity.
0 to infinity, t into e power minus st dt, because in this interval u of t amplitude is 1. From minus infinity to 0, there is no amplitude for u of t. Now here we have to use the integration formula, integration of, or UV rule also you can use if you can remember that. Otherwise you can go for this, use directly this relation, integration e power ax by a square into ax minus 1. Use it. Use this. In place of x, what we have here, t is there. And in place of a, minus s is there. Substitute, just a substitution now. Just a substitution. Now let us continue that. X of s, t into e power minus st. 0 to infinity, e power ax. E power ax by a square means what I have to write? E power minus st by, in the denominator, a square. In place of a, what we have? Minus s is there. So it is plus s square. Ax minus st minus 1. Now what is the restriction on s here? When this is going to be infinity, if s is less than 0, if s is less than 0, minus into minus, it will be changed to plus. So definitely here we will get a finite value of this integration or this substitution. Integration value itself is this, right? Or substituting upper limit minus lower limit. There is no problem with the lower limit 0. But when you substitute here t equal to infinity, e power minus infinity is 0. No problem. But the thing is that if s is greater than 0, definitely s must be greater than 0. If s is less than 0 means what happens here? Less than 0 means negative value will be there here. Minus into minus will change to plus, and e power plus infinity will be now plus infinity. That's why here s must be greater than 0. So now you can substitute upper limit and lower limit. Anyhow, 1 by s square is a constant. Let us write it outside. Now, what are the limits we have? E power minus st into minus st minus 1. Upper limits. These are the limits. So here 1 by s square. First I am substituting upper limit. E power minus infinity minus 1. Minus of lower limit is minus 1. E power minus infinity is 0. 0 multiplied with infinity or whatever may be the value, it is 0. Now 1 by s square. And what is the restriction here? Real part of s must be greater than 0. Clear this? Yes? Do you want me to repeat any step? Tanush, Shiva, Ganesh? S must be a positive quantity. Substitution of upper limit and lower limit. E power minus infinity is 0. So no need to consider upper limit at all. 0. Substitute lower limit. 0. E power 0. E power 0 is 1. And here S is T value is 0. Minus 0, minus 1. Minus of minus 1. Lower limit. Okay. So here, Nandini, are you there? Is this clear?
Yes, ma'am.
Okay. Now, how many poles are there? U of t. T into U of t. What is the Laplace transform we got? 1 by s square. And what is the ROC? Real part of s must be greater than 0. So, if you write it in a plane, real part of s and then imaginary part of s, one pole at origin. And what about ROC greater than 0, right? So greater than 0, exactly at 0, draw a straight line. Greater than 0 means this side. So only this side. This is nothing but your ROC. Clear for this problem? So like this, try to represent ROCs also for all the problems. So I'm erasing the content on the board. Hope you have copied. Okay. Next, fourth one. Find out the Laplace transform of same formula we are using, e power minus 80 into u of t. Try to solve this. Find Laplace transform of the signal x of t equal to e power minus 80 into u of t. What is the formula we have? Signal multiplied with kernel. Now in place of x of t, what I have to write? As u of t is there, what are the limits I have to select? Because only positive side u of t will be existing, and in that positive interval u of t amplitude is 1 minus of s plus a into t dt. Clear? Now 0 to infinity. What is the integration of this? Minus 1 by s plus a into e power minus of s plus a t. T limits are from 0 to infinity. So now let us take minus 1 by s plus a outside. Now observe here, what are the limits we have? 0 to infinity is there. And while substituting the limit, e power minus s plus a into t is there. So definitely, what is the restriction here? What is the restriction on this exponent? It must be a finite quantity, Ravali. It must be convergent. When it is convergent, I should not get infinity here, isn't it? So definitely here s plus a must be a positive number. If s plus a is a positive number, e power minus infinity 0. If s plus a is less than 0 means minus into minus will change to plus, e power plus infinity it will be. So here this integration will be definitely convergent. It is going to be a finite quantity if this exponent, in this exponent s plus a is greater than 0. If this is a positive quantity, positive number, then only this integration is convergent. Clear this point? So now you can substitute upper limit and lower limit. Now what is this value? 0, and this value is 1. So this is 1 by s plus a, and what is the corresponding ROC? S must be greater than minus a. It implies that real part of s, we want only real part of s in Laplace transform, isn't it? Real part of s must be greater than minus a. So here e power minus 80 into u of t, its Laplace transform is 1 by s plus a. Completed this? 4B9. Okay. E power minus 80 into u of t is 1 by s plus a. So what is the corresponding ROC? Real part of s is greater than minus a. Hope you have completed this. Copied? Yes. So now try to draw the S-plane representation. ROC, try to represent ROC in S-plane. So finally we got here e power minus 80 into u of t. What is its Laplace transform? 1 by s plus a. And what is its corresponding ROC? ROC antene real part of s greater than minus a. So here this is our x of s function, right? This is our x of s function 1 by s plus a. How many poles we have? Poles. Poles are nothing but roots of denominator. S equal to minus a. Means no imaginary part is there. Only real part we have. So in S plane, this is real part of S and this is imaginary part of S. S equal to minus a will be here, which is one pole. Now, if you represent ROC, real part of S is greater than minus a. So your ROC is greater than means this entire right hand side is your ROC for this problem. Real part of S is greater than minus a. Like this you have to represent. Next, one more point we have to observe here. Here, what is the input signal that I have taken? What is the input signal that I have taken here? X of t is e power minus 80 into u of t, right? So this is an example for causal signal. Causal signal. How can we say that it is a causal signal? Because the signal will be existing only in the first quadrant, only for positive values of t. Hence the signal is causal signal. So here you can conclude that, please write a note. For a causal signal, ROC is greater than its pole. For a causal signal, ROC is greater than its pole. You can observe here, right? This is our ROC. ROC is real part of S, which is greater than pole minus a. Completed? Shall I go for next problem? Manasa.
Yes, ma'am.
Okay. Completed, ma? Okay.
Okay, ma'am.
So this is a type of input which is existing only in the first quadrant. So with the signal which is existing for positive time values is known as causal signal. So for a causal signal, ROC is greater than its pole. So this is an example. Causal signal I have taken and we got ROC as greater than its pole. Okay. So let us go for next problem. So we have completed causal signal. Now let us try to solve it for non-causal signal. Okay. Anti-causal. Next problem. I think this is a fifth one. Find, try to solve this everyone. Laplace transform of x of t equal to minus e power minus at u of minus t. Try to solve this. Minus e power minus at u of minus t. U of minus t is there means definitely it will be existing in the second quadrant. Means this is an example for anti-causal signal. This is an example for anti-causal signal. Okay. Now let us try to solve this. X of s. What is the formula we have for Laplace transform of x of t? Signal multiplied with kernel. This is a standard formula what we have to find Laplace transform of the signal x of t. Now x of s equal to minus infinity to infinity. In place of x of t, what I have to substitute now? Minus e power minus at u of minus t e power minus st dt. Right? So u of minus t is there. So what are the limits I have to write? Minus infinity to 0 e power minus s plus at dt I am writing. Okay. So here minus is there. So let us interchange the upper limit and lower limit. Okay. So here minus is there. Upper limit has been changed to lower limit to upper limit. Okay. Next, here we want, these are the limits for what is a variable t limits, right? So here I want plus infinity. So replace t with minus t both in limits and as well as in expression. That means integration. So many times we used in previous problems also this method, replacing t with minus t both inside the integration as well as in the limits. So here, after replacing t with minus t equal to 0, minus t equal to minus infinity, and here it will be changed to minus t. And what about dt? That will also be changed to minus dt, because when you change t with minus t both in expression as well as in limits, there will be no change in this entire expression value. Function value won't be modified, because both in limits and well as expression we are doing the change, both are get compensated. So function value will remain same. Okay. So now minus dt is there. So let us write minus outside, t equal to 0 to infinity, minus of what I have to write here now? S plus a t dt. Okay. Clear? Up to this clear? Do you want me to repeat any point? Important, these two problems, repeated questions. Find Laplace transform of positive sided exponential as well as negative sided.
Ma'am, can you repeat last step, madam?
Okay. Which one? This one?
Below my last step.
Okay. See here, actually limits are from minus infinity to 0 are there. Here minus is there already in the expression. So I have interchanged both the limits, minus upper limit to lower limit to upper limit. So this minus will get compensated. Here I want plus infinity here. Generally we deal with plus infinity. You can also proceed with these limits also. Finally, the functional value will remain same. The procedure what I am using here is instead of minus infinity to get here plus infinity, replace t with minus t both inside the integration as well as in limits. Then that won't change the function value, integration value. After solving this integration, whatever value we get after replacing t with minus t, it remains the same. Without changing or with changing, the function value will be same because we are modifying t both inside the expression as well as in limits. Clear? First of all, understand that point. After that, wherever t is there, replace with minus t. Minus t equal to 0, t with minus t. Minus t equal to minus infinity. And here also t with minus t. dt will also be changed to minus dt. Now I want limits for only t variable. T equal to minus 0. Minus 0 or plus 0, that remains same. Now what are the limits for t here? Minus minus will get cancelled. T limit will be from 0 to infinity. Here minus dt is there. So I have written this minus outside. Now minus into minus will be changed to plus s plus a into t. Now it's clear, I think. Yes. ఇంకా ఏదైనా స్టెప్ రిపీట్ చేయమంటారా? So now listen here. 0 to infinity. What is the integration here? 1 by s plus a into e power s plus a t. Right? So here directly if you substitute t limit, what we are getting? Infinity, right? Isn't it? We are getting function value as infinity. So here if s plus a is greater than 0, if s plus a is greater than 0, this expression, total expression value, we are getting it as infinity. So here what is the restriction? Definitely we have to assume that s plus a is less than 0. That integration is convergent. If s plus a is less than 0, then only integration is convergent. Okay. So here if s plus a is less than 0 means minus 1 by s plus a, we will get, if this is less than 0 means negative sign will be there. So e power negative sign minus infinity e power 0 plus 0 or minus 0, that doesn't matter to us, 1 by s plus a with the restriction that s plus a is less than 0. This is a twist here. So please observe here, if s plus a is greater than 0 means e power infinity. Integration is infinity. So if s plus a is less than 0 means here minus will be there, e power minus will be there. So then only e power minus infinity is 0, integration is convergent, a finite value we will get. So that is the assumption here. If s plus a is less than 0, then only we can further proceed. If it is greater than 0 means e power positive infinity. Integration is not convergent, infinity we are getting. So if it is s plus a less than 0 means e power minus infinity is 0. And e power plus or minus 0, whatever may be the exponent here, positive or negative, 0 value is 1. 1 by s plus a only we will get. But the restriction is that s plus a is less than 0. So like this, the analysis is important here. S plus a we have to select it as greater than 0 or less than 0 when the integration is convergent. That is important. That analysis is important. So any doubt? Do you want me to repeat in this step? Like how why I have selected S plus A is less than 0? Just we are assuming that S plus A is a negative quantity. If it is negative quantity, then only e power minus infinity will be there. And it finally we are going to get the value as 0. Otherwise, the integration value is going to be infinity. That's it. Clear? Diploma students. Bhargavi, Pranita, Joharika. Shall I erase the content?
Yes, ma'am. Clear. Yes, ma'am.
So here mainly what we have to understand here is e power minus 80 u of t. Previous problem we got it as 1 by s plus a, but real part of s was greater than minus a. Now whatever problem we are solving, that is minus e power minus 80 u of minus t. What we got? We got the Laplace transform as 1 by s plus a. But the restriction is that s plus a less than 0. That means s is less than minus a. Means real part of s is less than minus a. Because here what is s actually? Sigma plus j omega. Isn't it? Plus j value is not there here. So we don't want omega variation here at all. For ROC existence, from the definition of ROC, we want only real part of s. So real part, only real value we have here. So real part of s is less than minus a. Put it in a square box that u of minus t Laplace transform is 1 by s plus a, where real part of s is less than minus a. Nothing but your ROC. ROC is less than minus a. So here the conclusion. Write a note here. For an anti-causal signal, ROC is less than its pole, because minus a is the pole value, denominator roots. S plus a equal to 0 means s equal to minus a. Minus a is a pole value here, and ROC, real part of s is nothing but ROC, less than its pole value. So that is one of the properties we are deriving for ROC here using these examples. First I have started with causal signal, positive side exponential, real part of s is greater than its pole. For an anti-causal signal, you can observe here Laplace transform is same for both the time domain function, but there is a change with respect to ROC. So while finding inverse Laplace transform, if 1 by s plus a is given, whether we have to choose this signal or this signal. How can we select whether this time domain function or this domain function? Based on this ROC only. If ROC is greater than minus a means this Laplace transform, inverse Laplace transform pair I have to select. If this ROC is given means this time domain function I have to select for the given Laplace transform function. Clear up to this? Copied this entire thing? Okay. Next problem. Next problem, whatever may be the number here, write down. Find out Laplace transform of the signal x of t equal to e power minus 3t u of t plus e power minus 2t q of t. Find out Laplace transform of the signal x of t equal to e power minus 3t u of t plus e power minus 2t u of t. Sum of two causal signals here. This is one causal, this is one causal. Previously, only one causal signal was there. Now, sum of two causal signals are there. Try to solve this. X of s. Nothing but Laplace transform of x of t. What is the formula we have? Signal multiplied with kernel. In place of x of t, what I have to write now? U of t plus into e power minus st dt. So u of t is there as usual in both the terms. So u of t is there means definitely what are the limits I have to take? E power minus 3t plus e power minus 2t now, because u of t will exist only for positive time values, and within these positive values its value is 1. So now 0 to infinity, you can write it as e power minus 3t into e power minus st plus, split the integration. So now try to solve this. 0 to infinity e power minus s plus 3 into t dt plus 0 to infinity e power minus s plus 2 into t dt. Okay. Now tell me when this integration is convergent. E power minus infinity I have to get. E power minus infinity means this integration is convergent if s plus 3 is greater than 0. Similarly, e power minus infinity I have to get, means s plus 2 must be greater than 0. So don't forget that point. Now tell me what is the integration of this? Minus 1 by s plus 3 e power minus infinity minus e power, directly I am writing minus 1 by s plus 2 into upper limit minus lower limit 1 by s plus 3, because e power minus infinity is 0, minus of minus will change to plus 1 by s plus 2. But what are the restrictions? S plus 3 must be greater than 0, means real part of s greater than minus 3 and s plus 2 greater than 0. That means real part of s greater than minus 2. Clear up to this? Yes, any doubt? So here finally x of s is, take LCM, simplification. Nothing is new here, just you have to simplify the function. What about numerator? S plus 2 into s plus 3. S square వస్తుందా ఏమొస్తుందా? S plus 2 plus s plus 3 కదా, 2s plus 5. Now real part of s greater than minus 3 and real part of s greater than minus 2. Now observe here, try to draw the representation in S plane. Here we have real part of s, here we have imaginary part of s. What is the first restriction I have? Real part of s must greater than minus 3. So here minus 3, here minus 2. Total how many poles we have for this function? Denominator, what are the factors we have? S plus 2 into s plus 3. What are the roots of this denominator? Minus 2, minus 3. So these two are nothing but poles also. isn't it? -3, -2. These two are also poles. So here, let us draw two lines at poles. Now, first, what we have? Real part of S is greater than -3. Greater than -3 means positive side. Next, what is the other one we have? Real part of S greater than -2. Greater than -2 means from here onwards. Then what is a common ROC we have? There is a common ROC. This is the common ROC what we have. So here, real part of S greater than -2 is the common ROC for the given signal. So what is the conclusion that we can do from this problem? If the given signal is a combination of two causal signals, then the ROC is greater than maximum of its poles. How many poles we have? -3, -2. So ROC is greater than maximum of how many poles? -3, -2. What is the maximum number out of these two? -2. So your ROC is greater than maximum pole value. ROC is greater than maximum. Common region we have to select. Greater than -3, greater than -2. Both we have represented. So where is the common region? Greater than -2 is the common region. So here, if the signal is a combination of two causal signals, means conclusion is that your ROC is greater than maximum of its pole values. There may be 3 number of poles, 4 poles may be there. Okay. If it is a combination of all causal signals, means maximum pole, whatever number is there, ROC is depending on that maximum pole value only. That is a conclusion. Clear? So please write your note over here. If a signal is a combination of, means sum of, combination means combination of two causal signals, then its ROC is, if a signal is a combination of two causal signals, then its ROC is greater than its maximum pole value. If a signal is a combination of two causal signals, then the ROC is